How's it going, everybody? My name is Snowboard Otter, and welcome to the first devlog that I'm making for my Frogger-inspired 3D grid-based platformer made in the Godot engine called Hopper. Hopper is inspired by Frogger He's Back. This was one of my favorite games growing up as a child, and for my first real project as a game dev, I wanted to make something that I was familiar with, but obviously the frog was taken, so I thought to myself, what other animals hop? And I settled on a kangaroo. You'll be playing as a kangaroo that has to collect 5 different mini kangaroos, mini kangaroos, baby kangaroos, and under a certain time limit. And once you collect all 5, you'll be able to go on to the next level. So for this devlog, I wanted to take you guys through how I implemented a grid-based 3D platformer character controller in the Godot engine. Today, I'll be going over most of my player scene. This will include things like input collection, state machine, and individual states, and also go over my camera system. And if you want to follow along with the development of Hopper, don't forget to subscribe. With that, hope you enjoy the video and let's get into it. All right, so the first step to getting our player to move is to collect inputs from the player. But before we get too granular, let's take a high level look at how input data flows through our player scene. I have an Area 3D node as the root of my player scene, and I have 2 custom nodes attached as children, the player state machine and the input component. Every frame, our player is going to be asking our input component to gather all the input that happened on that specific frame and compile it all into an input package. Once our player script receives that input package, it's going to check if it's empty, and if it's not, it's going to send that to our state machine, where our state machine is going to find out which of those inputs has the highest priority, and then send that highest priority move to our current state. In a previous build of this character controller, I was collecting input everywhere in my player script. I was collecting it in the idle state, in the move state, and passing it around to other states, and it just turned into one big mess, and it was really hard to debug. So my solution for this was to centralize all my input collection into one scene that I could attach to my player scene. This is where my input component scene comes into play, along with 2 custom resources that I made, the action request and the input package resources. Just as a quick disclaimer, this whole input package system was not invented by me. I took inspiration from another Godot YouTuber called Fairfight. He does a lot of Souls-like videos, and if you guys have seen from my channel, I'm a pretty big Souls-like fan, and that was one of my early projects, was trying to make a Souls-like. He showed the system in one of his videos, and I kind of like it, so I used it and, made it my own a little bit as well. So now I'll show you all how it works. The first custom resource I have is the input package. All this is an array of action requests. The action request is just another resource with 3 variables, the type of move it is, the priority, and its direction. As an example, let's take a look at what happens when our player presses jump and forward at the same time. Once any of these inputs are pressed, we're going to create a new variable and assign it a new action request resource. We're going to assign that action request a type, a priority, and a direction, and we're going to add it to our input package. Once our player sends that input package to our state machine is going to look at both of those action requests. It will see that jump has a higher priority than move forward, and then it'll send the jump input to our current state. Now you may be thinking this is a bit overkill just to have the player move and to jump, but I think the advantage to this is that all that I have to do to add a new movement input or input in general is to just assign it a new action request. Then I can just go into one of my state scripts and determine what I want that input to do in that specific state. So I think this system adds a lot of modularity to my code. Now that we're collecting input from the player, let's take a look at our individual state scripts and see how we move the character from these inputs. Really quick, I want to talk about how I was moving my player before this implementation and the problems that came along with that. Before using an Area 3D as my player node, I was using a character body 3D and moving the player via velocity. I would calculate my player's target position and direction similar to how I'm doing now, and I would apply a velocity in the direction of the next position. Once my player's actual position was within a certain threshold of my target position, I would set my player's velocity back to 0 and then transition to the idle state. This approach caused a lot of problems and headaches, one of those being a lot of inaccuracy on the move, so I had to implement a snapping feature to my player once it completed the move. Snapping the player to the grid would just make sure that it doesn't drift off the grid too much. And I also had a problem with slopes. For some reason, when I would go from a flat surface to a downward slope, my player would hover for a little bit and then fall down onto the slope. I know why it happened, but I couldn't for the life of me figure out how to solve it. So that was the final straw. After that, I decided, screw it, I'm going to a Area 3D player with a tween-based movement system, and that's what I'm going to show you guys now. So what needs to happen when a state receives input? It needs to find data for the next move, such as target position, and it also needs to check if that move is valid. To get information on the next move, I created a new resource called Move Data that contains all the information that our player needs to know about the next move, such as start position, target position, direction, and slope angle. Getting most of this information is pretty simple, but I do want to go in depth on how we use raycast to get a lot of this information. So the first thing we need to do is just get our target horizontal position. This is pretty simple because our inputs already have a direction associated with them. So all we need to do is multiply our input's direction by our grid size and add it to our global position. Then we give that target horizontal position to our ground detector, and I swear guys, the ground detector is the MVP of our movement system. It only has one function called move, where it moves to our target horizontal position, but a little bit higher, and shoots a raycast down, colliding with the terrain. We can use the raycast built-in functions called getCollisionPoint and getCollisionNormal. The y component of our collision point is going to be our new height, and the collision normal is going to tell our player if the slope is too steep. Now that our player knows all the information about the next move, the next thing it wants to know is if we can even move to that position or not. In addition to checking if the slope is too great for our player, we have a series of raycasts pointing off in each direction from our player that can block movement if we're going to collide with a wall. This is all controlled by our collision handler node. It's basically a really big match statement that matches the direction of our move with any of these raycasts. So if we're moving forward, our collision handler is going to ask our forward raycast if it's colliding, and if it is, it's going to block that move. I was having a problem when I was trying to go up slopes that my collision was still being blocked by these raycasts. I used the collision angle to check if what I'm colliding with is either a wall or a slope, and if it's a slope, I bypass the check, and if it's a wall, then I block the move. Like I said, it's a little bit weird, but it works. If our move passes all those checks, we can tell our state machine to change the state. Our move state's pretty simple, so let's go over that first. First thing we do is we get the next position from our move data, and then we create a tween and tween our player from our current position to our next position. And that's it. Like I said, pretty simple, so let's go over our jump state next, which is a little bit more complicated. To get our player to jump, we're going to use a node built into Godot called the Path3D node. Our jump path has no points to begin with. Instead, we generate those points in our script. Getting the start and end points for our jump is the exact same as we do when we move, but we also need to get the apex of our jump, so we go halfway in between jump start and jump end and add our jump height to the y component. That way we have 3 points to add to our jump curve, and when we set the bake interval to 32.5, it creates a really nice parabola for our player to travel along. We can tell our path follow 3D node to move along the jump curve at a specific rate, and every frame we can set our player's global position to match the path follows global position. That way it'll look like our player's moving along the jump path. And then, once our jump progress is greater than or equal to 1, we can exit the jump state. One really important thing to know about our jump path is that it's not a child of our player, it's actually a child of the world that we're in. So to get a reference to the jump path, I assigned it to a group called jump path, and then just use the getTree function and .get first node in group. And once we do that, we just assign it to a variable called jump path, and now we have a reference that we could use. The reason I did this is because if the jump path was a child of our player, once we change our player's global position as it goes along the jump path, our jump path will also move up. So it'll result in this like exponential growth of our player's height. So we want to keep this as a child of the world or level that we're in, so our player's global transform is not influencing the jump path at all. Now there's 2 scenarios we could be in once we exit either the jump or move state. Either there is ground below us or there is no ground below us. Our player has a raycast that points down, and if it's not colliding, then it's going to tell our player to fall, but if it is, we're just going to transition to idle. Our fall state's really simple. All we do is we move our player down until that down raycast is colliding, and then once we exit the state, we snap our player to that raycast's collision point, just so we're not clipping into the ground or floating a little bit above it. And just like that, we return to the idle state and the whole cycle can continue again. Now, you may have noticed when we assign a direction to an input or a movement, we have to rotate it based on where our camera is facing. So to wrap this video up, let's take a look at our camera script and see why we have to do that. So our camera setup is pretty simple. All we have is a node 3D at the center of our player called camera focus, and we have a camera attached to that node that's pretty high and looking down so we can get a top-down view of our player. We do it this way because once we rotate our camera focus around its y-axis, the camera swings along with it and it's always going to be looking at our player. So this makes rotating the camera a lot easier, and all we have to do is rotate in 90-degree increments, and we pretty much get perfect rotation every time. Now we can take a look at our camera script where you'll see it's pretty simple. We have an enum that tracks what state our camera's in, either idle or rotate. I haven't added zoom yet. All we're doing in idle is waiting for a rotation input from the player, which is either going to be -1 or +1. And once we get that, we can find our target rotation by multiplying our rotation increment in degrees, which is 90 degrees, by our requested rotation, and then add that to our rotation degrees. Then we switch to the rotate state where we rotate our camera to our target rotation. Once we get close to our target rotation, we snap to our target rotation and then switch our state to idle. So yeah, it's a pretty simple camera controller, but adding in rotation complicates our movement system a little bit. If we kept our movement input the same, even if our camera has been rotated, it leads to some very unintuitive controls. So if we were to rotate the camera 180 degrees, up would be down, left would be right, and everything would be flipped basically. So that's where the rotate function comes in our direction. We rotate our direction vector based on the rotation of our camera, so that once our camera is rotated, our forward button is always going to be forward and our backward button is always going to be backward, and so on. This just makes all the controls a lot more intuitive. All right, everybody, that's going to do it for today's devlog. Hopefully you all enjoyed. If you did, be sure to leave a like and subscribe to the channel so you don't miss the next devlog. Next time, I'm going to be adding moving platforms to my game, and I'm pretty sure that's going to break everything, so stay tuned for that. Leave me your thoughts on this devlog in the comments below. This is my first one ever, unsurprisingly, most likely. But if there's anything that I did that you liked, be sure to let me know. And if there's anything I can improve on, also be sure to let me know on that as well. If there's any OGs watching this channel, I appreciate you. I'm 26 now, and I started this channel when I was 16, I think. And yeah, pretty crazy. So if you guys are still here from those days, let me know, and thank you. And also thank you to anyone that's new for joining me on my game dev journey. This channel is pretty much a place where I post anything that I'm really passionate about. You know, it used to be Call of Duty, then it was skateboarding, and now it's game dev. I had a different channel where I was posting Minecraft videos. I'll leave that in the comments down below if you guys want to check that out. But yeah, I just like sharing my passions with you guys. Hopefully you all see that and enjoy the content that I make out of it. But anyways, I'm going to end the video here. Thank you all for watching once again, and I'll see you all in the next devlog. Peace.